Trees come in a variety of specialized types, right, that are customized to specific applications. So a so-called rooted tree, for example, is particularly well suited to describing hierarchies that have a well-defined object or person at the top. People are assigned to that object, then people are assigned to those, and so on down into the tree. Now, what distinguishes a rooted tree from a regular tree is that a rooted tree has one vertex that's designated the root, or continuing our botanical terminology theme, and it's usually at the top of the tree with its descendants radiating down from it. V1 at the top of the example here would be its root. Now, I know there's quite a list of definitions here, but I think they're clearer if we look at some specific examples, right? For example, look at vertex V5. The level of V5 is going to be 2, since there are 2 edges between it and the root. V9 and V10 are its children, and they would be siblings of each other. Going up a level, V2 is V5's parent, and similarly, V5 is the parent of V9 and V10. Also, V9 and V10 would be the descendants of V5, and V1 and V2 are the ancestors of V5. Okay, and finally, the greatest height is the distance from any of V7 through V11, anything in the bottom row there, up to the root, which makes the height of the tree 3. From an application perspective, there's often a clear choice for what should go in the root position. For example, the root of a file system or the CEO of a business. From a theoretical perspective, on the other hand, any vertex can be assigned the root position. These two trees, for example, are isomorphic. Remember that means that they're effectively the same graph, but with a different vertex pushed up into that root spot. So a binary tree is a further refinement of a rooted tree. Right? So in addition to having a root vertex, binary trees have the additional requirement that every parent can have at most 2 children. And if every non-leaf vertex in a binary tree has the full 2 children it's allowed, then it's what's called a full binary tree, which this one isn't, because V3 here only has 1 child. Right, so each child is designated either a left child or a right child. For example, V6 is the left child of V2, and V5 is the right child of V2. And the subtrees, starting with a left child as their root, are called left subtrees, like this one here. This would be the left subtree starting at V6. And the subtrees that have a right child, like this subtree here, are the right subtrees. So we've seen a lot of definitions and a lot of theory so far. I wanted to just kind of take a quick diversion here and talk about a quick example of what we can do with these trees. If you get your calculator out and you enter an expression like this, your calculator just kind of lets you enter all these numbers and symbols and so forth, and when you hit the equal sign, it somehow not only remembers the numbers and the symbols, but it gets the order of operations straight. Right? So how does it do that? Well, one approach to this is to store this information in a binary tree. For example, let's say you get your calculator out, you enter 4, and then you enter the division sign, right? Well, that's going to be a parent of the 4, right? The operations are going to be the parents of the things they act on. Then you type the 2, right? So that goes next with the division. Then you do the plus, then the 3, then you're going to do multiplication, then a 4 plus the 1, and now we're done, right? These are all the symbols. You hit the equal sign, your calculator kind of fills the tree back up to the plus, and now it can take this tree, and by doing a special kind of what's called a traversal, where it goes through every element of the tree one at a time in a specific order, it can work its way back through the order of operations and end up with the correct result. We'll talk a little more about traversals in an upcoming lecture here. So what's next? We're going to kind of follow a familiar pattern now that we have this new structure, right? Two structures really, rooted trees and binary trees. We're going to take a look at some of the properties of those objects.